Okay, for tonight's homework, and there's a lot going on tonight. All right, we got two big things we got to discuss. One of them is factoring, and one of them is simplifying. All right, two big concepts for us this year, major concepts for this year, and so we're trying to get you started on this. So we'll get through this. The first half of your homework is all about factoring. 1 through 8 is all about factoring. All right, and so 8F plus 12. So what we want to practice tonight or be able to do after tonight is if we're given an expression such as 8F plus 12, all right, we want to be able to factor that expression so we can come up with another version that's equivalent. Okay, we are not solving anything tonight. We are not finding any answers tonight. It's all about, can we find another expression that is equivalent to this one? All right, and for a lot of us, when we think of factors, okay, two operations come to mind, multiply or divide. All right, and we're looking at division. Factors. I need a common factor for 8F and 12. I need a value that I can divide both of these by. Okay, and so one of those you might be saying right now is that we can divide them both by 2. Okay, so if we want to use 2 as our common factor, that basically means that we're going to divide this term by 2 and divide this term by 2. That results in a 4F. 12 divided by 2 is a 6. All right, that's one equivalent expression. We write the 2 out front because this is our common factor. That way we all know what number that you're using. This little divided by 2 and divided by 2, that's your work that you can show. Okay, but this is your common factor here, and these are our new terms. All right, some of you maybe wanted to use 4 as a common factor because we can divide both of these terms by 4. So if that's the case, we would put our common factor 4 out front. Our two new terms, 8 divided by 4 is a 2F, and 12 divided by 4 is 3. So that would be another equivalent expression, an alternative approach to factor our original expression. Okay, so what we've come up with now is 1, 2, 3 versions of the same expression that are all equivalent. Factoring. Now the nice thing is though, okay, is we can also 6k to the second power minus 4k. We can do more than just factoring out of numbers. If you notice in this expression, both of these terms have a common factor of k. So if we would like, we can factor a k out front, all right, which again means we're going to divide by k and divide by k, all right. So factor, actually if we look at this term, you might get a better visual. K over k, those basically cancel each other out. We're going to factor that k out and put it in the front, which means now we only have a 4 left in this term. All right. Here, we're still going to have our 6. We got k to the second power over k. All right, so again, over here, a little sidebar. All right, k to the second power expands to k times k, and we want to factor out a k. We still have 1k left. So we would still have a k here. Notice there's no longer a need for the second power because we only have 1k. All right. So we can factor variables as well as numbers. And I just happened to notice, since I was so focused on my letters, that 6 and 4 also have a common factor. All right, we can divide both of these by 2. So if we wanted to keep moving with this, we would now move our 2 out front. So we would have a 2k. 6 divided by 2 leaves us with a 3k, and 4 divided by 2 is a 2. All right, so that was completely by accident, not part of the original plan, but after we factored out the variable, I then noticed we could also factor out a 2 as well. So not only can we just factor out numbers, We could factor out a variable, or you might end up doing a number and a variable. Okay, not very often, but sometimes that stuff happens. Okay, so that's our factoring. That should take you through 1 through 8 on tonight's homework. All right, 1 through 8. Now, the rest of the homework picks up down here, 9 through 14, with simplifying. And the big property today is the distributive property. Or, after you write it once, dprop, okay, our shortcut. Okay, now simplifying is all about making your expressions as simple as possible. Okay, as simple as possible. So if we're given an expression 8y minus 11 plus 3y, all right, as simple as possible. All right, so what the distributive property allows us to do, okay, is take a number on the outside and distribute through the parentheses. Okay, now if we're going to distribute, that means we have to give the 8 to all terms inside the parentheses. So when we say give it to, this means multiply right here. So 8 times y, we're going to represent that with an 8y, minus 8 times 11, 88. And again, notice the 3y is out here by itself. It is not affected by the 8. It's not in the parentheses, so no distributive property there. Okay, so we get to this point, and now we want to look for like terms. All right, terms that have something in common. And for this particular problem, our y terms, they both share a y, so they have a y in common. So 8y plus 3y makes 11y minus 88. Y term, this is just a simple whole number term. Okay, these are not like terms, so we want to stop here. All right, and our acronym, as simple as possible. We would consider that expression to be simplified. Okay, so that's the distributive property, and again, once we distribute, then we want to look for any like terms down through the problem. Okay, and again, on the distributive property, not all problems have to be set up the same. So, you know, we could do 11 plus y minus 6. We could distribute a y. Okay, we could distribute a variable here. Again, same idea. We have to distribute to both parts of the problem. Okay, now I'm going to start with my 11. It's unaffected because it's not part of the parentheses over here. Again, this is a multiplication step when we distribute. So y times y. All right, y times y. Shorthand version, y to the second power. Okay, so y times y, we can represent that as y squared minus y times 6. We can write that as 6y. Okay, we can write that as 6y. So now we look. I have a whole number term. Nope, no like terms with that. So the 11 is going to stay. We have a y squared. All right, now y squared is not the same thing as y. They have the same variable, but they are not considered like terms. This one's different. So this is my only squared term, and 6y, there are no other terms that look like this one. So actually, we can no longer add or subtract anything else, so we can, as simple as possible, represent that problem. Okay, a lot to do tonight. All right, it's a big challenge. Do the best you can, and your teachers will be ready for all your questions tomorrow. Just try hard. You'll be all right. Thanks. Have a good night.